Okay, welcome guys. This is our first lesson in College Trig. We're going to start right in chapter 5 and pretty much do most of the next 4 chapters. So this section is about angles and their measure. It's going to start getting us to think differently than you have been in your previous math courses and look at these angles, how we measure them, how we build the unit circle, and a lot of terminology we're going to use for the rest of the course. The first thing is, we know an angle is formed by 2 rays. So they meet at a vertex. We call this the initial side. Usually it'll be on the x-axis for us. We come up an angle here. This is alpha. You'll also see me use this theta a lot. Just know both of those are interchangeable. They both mean an angle. And then this up here is our terminal side, okay, where it ends, like a terminal stop for a train. Now, if we go counterclockwise, that's a positive angle. So this is going backwards of a clock. So we could say this is maybe, 36 degrees. Okay, in a positive direction. If we go clockwise, we get a negative angle. So if we wanted negative 36 degrees, we'd start at that vertex. We'd rotate this down. And, we could call it theta, we could call it alpha, whatever we wanted to do. Next is the idea of standard position. So when we say an angle's in its standard position, it means the vertex is at the origin with a basic XY axis, and the initial side always falls on the x-axis. So vertex right at the origin, you'll always have your initial axis here. Okay? Terminal side now is actually over in quadrant 2, so we know that has to be bigger than 90 degrees. We're going in a counterclockwise direction. So this angle is positive. Let's say this is maybe 135 degrees. Okay, so now you can see they use the theta. It'd be the exact same thing if they use an alpha. Okay, this is important. You guys have worked with degrees. You have an idea of where 317 degrees is. So now we're going to convert measurements into these ideas of radians. Okay. You need to be able to do things in both radians and degrees. Okay, degrees are pretty easy for us right now. Radians is going to be a bit of a challenge to get started here. So this is the biggest thing you need to realize. 360 degrees is 2 pi radians. The reason for that is we know circumference of a circle is 2 pi times r. The easiest number radius can be is a 1. So that makes circumference 2 pi. If you let the circumference be 360 degrees, that's what's in a circle. So then the ratio in a simplified form is there's 180 degrees in pi radians. So this point right here is 180 degrees or pi. This point over here is 360 degrees or 2 pi. Okay, so there's our conversion. Now, we can use this here. If you want to go from degrees to radians, you're going to have to use one of them. If you want to go radians to degrees, you're going to have to use the other one. Okay, so it's a unit conversion problem, really. So if we want to convert the angle negative 120 degrees into radians, so you want to get rid of degrees. Well, to do that, we're going to use this. Okay, it's the simplest one. 180 degrees is pi radians. You want to get rid of degrees, you put the degrees on the bottom. 1 pi radian is 180 degrees. Your little degree signs cancel. And you just simplify this, get rid of the zeros. Negative 2 pi over 3. So eventually we'll get to a point where I'll give you negative 120 degrees. So eventually we'll get to a point where you guys need to be able to know, pretty much off the top of your head, negative 120 is negative 2 pi over 3. Okay, we want to leave it like that. We don't want any decimals. The only time we'll take decimals is when it's not one of our special values and 120 falls in there. Okay? Now, what if we have something in 16 pi over 3? Clearly it's in radians because we don't see a degree sign. We want to turn it into degrees, So you want the 180 degrees up top. That means you want the pi on the bottom. Pi's will cancel. 3 goes into 18 6 times and add a 0. And this will come out as 960 degrees. Okay, so 960 is actually going to mean we're going to go around the circle a couple times before we stop somewhere, but we'll talk about that later here. Next, these are kind of some things to help you out as we build the unit circle the rest of this week. So there's certain tricks you can use, and obviously the more you practice it, the better you are with it. But eventually you want to be able to look at the fractions, figure out the multiple of degrees that it is, and try to apply it that way, if that makes any sense. So we know 2 pi is 360, okay? Now, we know 1 pi is 180. So a third of 180 is 60 degrees. So if we're looking at just half of a circle here, okay, 60, 60, 60. Okay, so things with 3s on the bottom are 60 degrees. We had 16 pi over 3. It came out to a multiple of 60 degrees. There was 16 of those 60 degrees. So 1/3 pi, or pi over 3, should be 60. 2/3 pi should be 120. 3 pi over 3 should be exactly 180. Okay, so a third of 180 is 60. So thirds mean, thirds on the bottom comes out to a multiple of 60 degrees. So now a sixth of 180 is 30 degrees. So if you're doing things with sixes, -7 pi over 6, it's going to be some multiple of 30 degrees. Okay? 30 goes into 180 6 times, so anytime you see a 6 on the bottom, it's a multiple of 30. Now a fourth of 180 is 45. Okay, so 4s on the bottom go 45s. Okay, that's pretty easy to match up there. So anytime you see 11 pi over 4, it's going to be some multiple of 45, and eventually you'll know all of those. Okay, so just some little things to kind of help you out if you want to put in your notes and keep to the side over the next couple days. All right, here's just kind of some basic practice here to draw each angle, get you guys in the habit of this. I'm going to pause it right here and put some of the work in and show you where these angles are. If you guys want to do the same and try them and also convert them, if you're not good with the radians yet, that would be a good time to do that. Okay, 60 degrees, pretty straightforward in quadrant 1. You can just approximate it, where it should be. Now, -120. Now notice what I did here. You could start at the x-axis and count backwards 90 and then approximate 30. I added 360 to it and just graphed a positive angle. Okay, so really you can add, subtract multiples of 360 to help you out, as long as you're in degrees. So that's the same thing as positive 240. 240 and 120 add up to 360. -2 pi over 3. So I converted this. Okay, I don't expect you guys to be able to work with the radians right now, but in the next couple days you should. I converted it. I got the same thing in -120. So -120, -2 pi over 3 are the same. You see 3's on the bottom, multiple of 60. Well, it's 2 multiples of 60, so -120. This time I did go clockwise with it. Lastly, 16 pi over 3, we've seen that before. I got 960, so I just kept subtracting 360 till I found something where it actually is. So these 3 angles here are all the same. Now, you could keep this in 16 pi over 3 and keep subtracting 2 pi's off of it, but we'll work on that over the next couple days. So that's going to be it for part 1 here. Jump on over and we'll quickly finish up part 2 with area and arc length.